exactly 5 o'clock, and I think we're on. So, what are we going to do today? On one of the previous, first of all, let me slow down. Hi everyone. My name is Zach, and I'm embedded software engineer, probably embedded systems engineer, and today what I want to do is work on exploring this RFC on the Zephyr RTOS project, which introduces LibMP, which is a media pipe library. And previously we've kind of run through and explained what all this is and how this works and what it introduces to us. But basically, in a very summary, in a very sort of summary introduction, this introduces a media pipe to Zephyr, and the media pipe allows us to do memory to memory sort of manipulation of buffers. And a good example of this is the stream that you're watching right now is made up of 2 feeds. So you have one feed up from my webcam, and you have another feed from my screen recording, and OBS is joining these 2 streams, and then it is showing and it's pushing this out and syncing it into something like GStreamer or FFmpeg, and eventually this is getting to RTSP, and it is getting to YouTube. And so basically this media pipe that is introduced ends up being the feature that you need to do things like that. So previously Zephyr only had like very primitive video drivers and kind of like very primitive buffer management, but with this media pipe we get to be able to I've been stressed today because I'm late. Anyways, so let's just knock it out, see what we can do, build up slowly, and see if we can actually get this thing to run. It would be nice to just get it to run today and show people how to run it. If you are here, just say hi. It would be really cool if you said hi. Feel free to ask any questions at any point, and yeah, cool. So today will be about mangling basically PRs and just planting PRs on top of each other so that we can make sure that we get it done. So the first thing we need to do is this PR depends on the following PRs. Hi Bartholomew, nice to see you. I don't know if this one is merged or is open. So is this one merged or open? This is open. Cool. And then this depends on audio. Do you do the audio one as well? I mean, we can't sort of ignore it, and it should still work, but I prefer not to. Let's just do it all. So let's actually check out all these PRs on our local machine, and then let's plant them all on top of each other. And then once we plant them on top of each other, then we can plant 98514. So there's 98500, 98513, 98875. So this is a later one. So perhaps we start with this one, and then we plant 513 on top of that, and then we plant 514 on top of that, and then we plant 875 on top of that, and then we have a PR that we can actually run, and this should be cool. An alternative way is to cherry pick commits. I don't want to do that today because I'm not used to cherry picking commits, really, to be honest. I'm not used to cherry picking commits, so I don't want to do that today. And if this goes particularly well and I can transfer it to a board, I will try and run it on our FPGA, which has 2 camera feeds, and that should actually enable us to see the M2M architecture work, which is memory to memory buffering work. But let's go baby steps. Let's actually get this sample running in native sim, and then we can go from there. And even if it's not in native sim, we can get it running on I think the FRDM. The problem is I'm not so sure about the RAM, the FRDM MCX and 236. Yeah. Anyways, questions before we start, and then as I check out this git check out. Oh, did I say hi, Bartholomew? Request locally. So let's go there. Yeah, I just need this. Yeah, this is kind of what I want. So cool. This is kind of what I want. Copy. And then we can just sort of jump into here, and I think we can go into our Zephyr project. Zephyr project. Yeah, clear. And then after Zephyr project, what we can't do, the next thing we can do is like, I probably think we can go to cd Zephyr, and then we can do git branch, and this should be in RFC LibMP. So let's leave that alone. And now let's come back here and get this, copy that, and then we can put this here. Once we do that, we can come back and I want to change this ID here, and then I want to just start with let's go here. Let's start with the earliest one. This is 98500. 98500. And then what is this one? Drivers LibMP audio. So let's say LibMP LibMP audio. So let's do that. Yeah, cool. Git branch. Clear. Git branch. So we should have LibMP audio over there. That's cool. And then we want to do 500. We want to do 513, which is video display. Video display 513. So that's 513. So gonna be LibMP video display. Let's check that out. Let's get that pulled and down, and then let's see 513, and then we need this is 514, which is RFC LibMP. That's fine. And then we want to do sysutil, LibMP sysutil. So that's cool. So let's get here, and then let's do LibMP sysutil. So that's going to be what? 98875. 875. So cool. Sorry about that. So let's pull that in. Let's sysutil, and then what else do we need? So we have video display, we have drivers audio, we have sysutil, and we have this one, the RFC. RFC for the media pipe itself. So I like going in order of the numbers so that it's easier to plant them on top of each other. And I think I'm gonna do git check out main, and then I'm gonna do a git pull. So I pull everything, clear, and then git branch, and then there's RFC LibMP. So that's fine. So git check out -b LibMP trial, and if this works, what I'll do is I will upload this trial branch on my fork of Zephyr, and then we can kind of explore it from there. So that's cool. So I would like to merge. If you merge it, which one goes ahead? You just merge this one onto that one. So you just do merge of the branch onto the thing. So it's fine. So you check out main, and then you branch. Okay, cool. So we are on LibMP trial, which is on main right now. So the first one we want to pull in is the earliest one. So 500, 513, 875, 500. So drivers audio. Git branch just to make sure we're in the same place. LibMP trial, and then you want to do git merge. It would be a nice time to learn how to do cherry picking. And I don't know if Bernard is online. If Bernard is online, he could probably help us to do quite a bit of cherry picking very quickly. And if anyone here kind of is very comfortable with cherry picking, you can actually let me know and I'll follow the instructions of how to cherry pick all the commits into one. But what I'm going to do right now is just merge things on top of them. And so the first one I said is going to be LibMP audio. Git merge LibMP audio. That should brr. Okay, clear. So that's there. Audio's in. And then after audio 500, we need 513 video display. Git branch, git log. So we have LibMP trial, merge branch LibMP. Okay, cool. So cool. That's Q. Yeah. Git branch. So the next one we want to do is videos display. So git LibMP video display. And then yeah, let's do that. So git merge LibMP video display. That should. Okay, cool. Git log. So now we're getting somewhere. So we have merge LibMP audio into LibMP trial, So that's cool. We have all of them. We have those. And then the third one. What's the third one? What is the third one? So 500, 513. Now we need to do 514, which is RFC LibMP. Git branch. It's RFC LibMP. Git merge RFC LibMP. Please just go. Okay. Okay, cool. That was the scariest one for me. Git log. Let's see if we're doing the right thing. So we have LibAudio, LibVideo display, LibMP, and then the next one just happens we want to do sysutil. Clear. So git merge LibMP sysutil. Boom. Okay, git log. So what have we done? We've basically, let's do it. So the first thing is we added LibAudio into LibMP trial, and then we added LibVideo display, and then we added RFC, and then finally we added sysutil, which is the order of which the commits appear. Before we actually jump into running the code, why don't we just check out, because we're here and we just did those things, why don't we just check out because right now, at this very moment, after I've done what I've done, I think it would be the most ideal moment for me to try and learn what git cherry picking is, and just to relate it to what I've just done. And also, if someone's watching later and they basically want to learn this, sometimes even me later when I go back to the streams and I try and learn the thing I did. So let's actually just go through, take 5 minutes, walk through what git cherry picking looks like and what it feels like, and then we come back and we run the LibMP thing, because it will probably run now. Git SCM. In the meanwhile, if anyone has any questions, please feel free to ask them. Or if anyone can teach me how to do this. Git cherry pick. So I want to see what git cherry pick is. Git cherry pick: apply changes introduced by some existing commit. Given one or more existing commits, apply the change each one introduces, recording a new commit for each. This requires that your working tree be clean. Okay, cool. the current branch and head pointer stay at the last commit made successfully. Git cherry pick. Let's see if there's something else. So it's just the same thing I've done basically. Let's look at stack. Cherry picking in Git means choosing a commit from one branch and applying it to another. This contrasts with other ways such as merge and rebase, which normally applies many commits to another branch. It is possible to cherry pick multiple commits, but merge is the preferred way over cherry picking. So you switch master and then execute the following. Git cherry pick the following. Make sure you're on the branch you want to apply the commit to, master, execute cherry, and then you add the commit hash. And if you cherry pick from a public branch, you should consider using X. This will generate a standardized commit message. This way you and your commit co-workers can still keep origin. So it's the same thing really. But let's also see what, perhaps let's also go see what Fee advised us to do the other day. So I'm just going to jump into the Zephyr project, and then I'm just going to jump into video. Just bear with me here. Bear with me. Let's jump into video somewhere here. I think it's going to be in subsys, isn't it? Video is a subsystem. Okay, cool. So here's a subsys. And then we're going to close this because we haven't gotten back to that. And then it says, but you need to cherry pick all the commits in the 3 independent PLs. You can exclude the audio PR. So basically we have done what we were advised to do. The merging is the same as the cherry picking. It's just in cherry picking, you can just pick one commit and then put it in your branch. If you only need one commit from somewhere else, you can just pick it up and you can put it in. So I think I feel confident that we've done the right thing. So let's try and run this thing on native C, yeah? And I think source, so I think this is gonna be //.venv.bin.activate. Okay, cool. And then the other thing we need to do is to now go back here and actually look at all the files changed. And then after we look at the files changed, we want to look at which sample we want to run. And then we might even open the sample and kind of explore it. But I think I can even do that from here. So let's go to Shift T. That's good. I want to move this here because I like my running window to be the last one here. Then I'm going to do an NVim here. And then I know I need to go to samples, and then in samples I need to go to subsys, and then I need to go from subsys I need to go to LibMP. So that is it. And then I want to go to video examples, and I want to know camera display, and then the first thing is I want to read a sample pipeline composed of 2 elements, a camera source and a display sink. This example demonstrates a pipeline consisting of 2 elements, a source and a sink. The source element, which acts as a capture device, generates video frames and pushes them to the sink element, which serves as a display device to render the content on screen. Requirements: a board with an input camera, a board with an output display support, sufficient RAM for video buffering. This sample has been tested on the following: native SIM64, RT1170 VK. I used to have that one, but I don't have it right now. It's not a big problem. We can still cobble up our own stuff. And as Bartholomew told me the other day, I should buy a display. It's coming. It's in the mail. So let's actually try and run this on native SIM and see what happens. So this is just basically if you have something like this and you have let's say you have something like this and you have a display like this. Actually, let's just use this broken one. You have a display like this. We're going to explore the code just now. What is going to happen is that LibMP will just source video from this camera into this display. Let's actually look at what the code looks like. I hope the code isn't too big, but it doesn't really matter if it's too big as well. So this is boards, this is build, this is camera display.c. CMake calls that camera display.c. Okay, cool. So camera display.c. What happens in here? First of all, let's actually go back and look at the project conf. Maybe there's a lot of stuff. So there's logging, config MP, yes, plugin zvid, zdisplay, display. So this actually introduces some plugins. That's cool. Nice. Config video, yes. Config display, yes. Shell, yes. Device shell, yes. Config it member, that's good. So this three is where the work happens. Config MP, config MP plugin, config MP plugin display. Why don't we just actually jump out? Shall we actually do MP plugin? Yeah, let's actually just try and see if we can do that. MP plugin. So that's not there. And then let's try and just find where that code is actually implemented, and then we can kind of maybe see what we can do. So I would go to subsys, and then in subsys I would go into libmp. I need to go out all the way into Zephyr itself. So here, into here, and I'll go into subsys, and I would find libmp, maybe. Lib. Excuse me. So just trying to find where this is actually. The other option is to just come here and see it's in lib. It's in libmp. Okay, cool. So let's leave the samples alone. Let's actually look at libmp. Well, first of all, let's look at kconfig. I need to blow my nose. Just let me mute for a minute. Bartholomew, if I forget to unmute, please tell me. Sorry, hay fever is coming back. Okay, cool. So let's actually do this. Let's actually explore this code. Now I want to look at this kconfig. Config libmp, so yeah, that's fine. So I don't want to see comments. Can I say I want to see comments? Let's open this in a new tab, and then we understand what's happening here, and then we can just jump into the so what does this do? Additional libraries, all it adds is libmp, I think. Cool. So libmp is added there. That's fine. That's okay. I thought I could hide comments somehow, but all this does is adds libmp, and then in CMake list itself, it also points us at the libmp subfolder. So let's open this libmp subfolder and config libmp, and I want to look at, there should be a CMake list in here or something. There should be a CMake list in here itself or something. It should actually tell me which where to go. Config libmp, that's it. So this is a proper library. This is heavy. It doesn't tell me where to jump into, but I would like to know where to jump into. This is where I'm supposed to go. How do I hide comments? How do I hide comments? I need to hide comments so I can just look at the files. Can I do that? Can I do that? Can I say something like, I don't want to see the comments right now. Yeah, cool. You can just minimize them. So let's look at it. That's a linker. And then in here, what is happening here? So this is just bool libmp add. Maybe it's even easier if we just try and trace it from, maybe it's even easier if we just try and trace it from the application rather. So yeah, sorry about that. We are discovering this. Now we're actually doing a review of LibMP. So yeah, cool. Okay, cool. So I'm going to Zephyr, samples, cool. Subsys, cool. And then in Subsys, I do have GD. Yeah, in Subsys, let's go into LibMP, video example, camera display.c. How many lines does this have? So, 90 lines. Oh, easy. We're gonna walk through this one. And the other thing I need to do is so that this is all not highlighted like that, is to copy into the Zephyr folder. Okay, let's cd ls, yeah, ls Zephyr. Is there a build in there? Okay, cp Zephyr build compile commands here, cool, and vim here, so that they can find my compile commands, and then into Zephyr, and then into samples, and then into Subsys, and then into LibMP, and then into video examples, and then into camera display, and we should have all the code finding itself now. Oh, we're done. But anyways, let's look at it. So let's now actually look at it. What does this do? We include libmp.h. That's fine. That's a library. That's a module in itself. And then let's see. We make an MP element, which is as a thing that creates a Z video source. It seems like Z video source is labeled with camera source. Where is camera source coming from? I want to look at boards. I want to look at this. So it doesn't tell me where camera source comes from. Everyone just wants to talk to me right now. Sorry, people. So cool. So we do MP element factory create. Does is this explained somewhere in the? Is this explained somewhere here in the conversation? Let's see. Or in the README? I don't think so. I just want to look at the conversation. Yeah. So we make a Z video source, and I think we label it as a camera. And then is there another thing? Is there somewhere else he explains what needs to happen? No, he doesn't. We are actually writing the documentation for this as we go along. So cool. Let's actually keep looking. So we make a element source, and can I GD? Okay, cool. Doesn't want to go find it for now, so that's fine. MP element factory create. What does that do? MP element factory. Let's look at. Can we find files changed? Can we look at which one is the MP element factory? So is there an element factory here? Element factory.c. Okay, cool. And then what is here? MP, it creates. It takes a const char factory name, ename, find f name, and then it does element. So you said element factory, it's ef, which is if ef, that's fine. and then element. How do we use the ename? How do we use an object name ename? Okay, cool. Okay, cool. So this is just basically using the structs. Fine. So okay, cool. That's what happens there. And then if source is equals null, we should fail to create camera source element. It makes a sync, which I think is labeled as a sync, and then display sync, and then if sync is equal to null, it refuses it, and then it sets the element properties. Set properties MP object that to that, and then creates a new pipeline, camera display, and if the pipeline doesn't work, it actually logs out, and then adds element to the pipeline. Order does not matter. Cool. So it adds MP bin, pipeline, source, sync, null fix, source sync. So how do you do that? Link elements together. So you add MP bin, pipeline. This is a pipeline you're adding. MP add to this pipeline, add this source and this sync. And then there's a null at the end. And then if this is false, you say it false to all other. And then you link them, MP element link. So the source is linked to the sync, and then I don't know what this third one is. And then there's a false. And then if it doesn't do that, and then you set the state to playing, and then changes the state, fail to start pipeline, return 1, otherwise cool. And then now you start doing queuing and unqueuing. So basically basically what happens is video applications become really simple, because if you explore something, let's actually go and look at the alternative here. Zephyr samples camera display, no? Let's look at samples. Video samples. It's not subsys now, it's going to be drivers, because it's not a subsys now, it's just video, it's just drivers. Okay, and then in drivers we're going to just go up and pick video. So this is the alternative, video, and then capture to LVGL. Well, we can just look at capture itself actually, source, and then we can look at the main. And then if we look at main number 1, it's how many lines? How many lines is this? It's like 1,000. As opposed to it's 400 lines. So this code just shrunk by a fourth. It's just a quarter of this. And what happens here is, like, you set up the camera, and you set up the display, and then once you set up the display, you add a display frame and all of these things. So you see, we're doing what LibMP does is it takes all of this work that you used to have to do for yourself, and then it takes it and it wants to go and do it for you. Basically is what happens. Cool. So, and then this is basically queuing and unqueuing. It just, you receive frames and then show them, and you receive frames and you show them, and yeah. So let's try and run that. West build -b dash b native sim dash pristine. Yeah. So that's build it. Okay, cool. I understand. So here we want to do native sim, and then we want to do our samples, subsys, libmp, camera display, our video examples, camera display. So let's build that. And why doesn't that work? Yeah, but there should be a pristine there. I mean, if you want to be such a rm-rf build, let's see if that works. I know that has been I've been moving really, really fast. Any questions about what I'm doing and what the advantages of this are, and any sort of questions? Any sort of questions? Or tell me what I'm doing wrong as well. You can do that. How can I make this better for you right now? How would you prefer I explain this right now? So this is actually not cool. Do I need to do some sort of thing like West Update or something? Do I need to do something like West Update? Is that what I need to do? So I can pull LibMP or something of the sort. And in the meanwhile, let's actually just pull this up, go into here and see what happens. And we were like, west build dash p, oh yeah, I see now. I never used the shield. So that's not gonna work. I never use the shield, so we can just go do that, and then in here, we can actually do it. Where do I usually do it? I can do it here as well. Dash S video. What is it? Video dash SW generate. So there's that. So I needed to add a shield, and the shield provides a software video generator, because we're gonna be running this completely emulated, and then we'll see what happens. Any questions so far? Just a moment. Okay, cool. So I remember something about this. I remember Joshua mentioning something about this, but it's in a sort of like private chat. So I need to kind of go to the private chat and fix it and look at it from there. So excuse me while I look at the solution for this. It's basically because I need some sort of SDL thing. Okay, so let's try that. Native sim, instead of just building for native sim, let's go native 64. Let's do that. So yeah, let's do that. That's good. This fixes it, because otherwise if we do this, SDL2 needs multi-bit 32-bit versions. Yeah, so we need to make sure that all the libraries line up basically. Sorry I couldn't show you guys that chart, that's fine. So this this kind of looks better now, and we should basically be able to run it. Does anyone have any questions so far? Am I doing such complicated stuff that I'm the only one who kind of gets what I'm doing? I wish to share this with everyone. So does anyone have any questions so far, please, while this is building? It seems as though this will build. It seems as though this will run. So cool. We can go dash. We can do this now. So this is built. Let's build Zephyr, and then something like in here there should be a Zephyr that I see. I think we can run that, and amazing. Exactly what I said it was. So this is exactly what I said. This is it. This is exactly. This is what exactly I promised would be. So I said adding, and we're going to try it again just now. Adding LibMP to Zephyr introduces the ability to do the kind of stream I am doing right now, which is I have a screen recording, a display, and then I have a little video recording at the bottom of the display. And the way we get those two things working together is that my camera will record a stream and my screen recording will record a stream, and then OBS will combine those streams and deliver them to something like RTSP, and we would get it. So basically, I can even show you this. I can show you this. Let me put in OBS here. It's going to be a little bit confusing because it's going to be mirrored in. But if I leave this here, don't look here because this is going to be quite mirrored. But what you see here is I have desktop. I have an internal camera, and I have. Let's do it this way. So if I do this, you see I have an internal camera and I have a laptop screen. If I do, let's say, take out the laptop screen, you can just see my video. And if I take out, say, the internal camera, you can see OBS. And basically, OBS is a M2M application. What it does is it joins two streams. Bartholomew wants me to explain what is being shown on this display. So let's go backward one step, Bartholomew, and then we come back to this so that you can see what is being shown. So first of all, let's play. Let's do native sim camera. Let's do native sim video capture, Zephyr display. Yes, let's do this. I know. Let me get you to the here. Let us build, before we do this one, before we do samples, subsys, all of that, let's do samples, drivers, video capture. Okay, let's run video capture just by itself so that you understand, Bartholomew. I want you to understand what it was showing. Okay, so let's use the software generator. Let's just run video capture, assuming this is just giving us it's just giving us a camera feed. Okay, so we're just doing video capture right now. And ideally we need to fix UVC very soon, because if we can fix UVC very soon, then I could have actually shown you this with actual cameras, but we haven't fixed UVC. This is another thing that fixing UVC is a separate thing from M6, and it's just all of these bugs we're discovering we need to fix, because that's the nature of life. If you discover a bug, you own it. That is actually something I should talk about more, because anyways, we'll talk about that later. So Bartholomew, this is just running the video capture samples, drivers, video capture. Okay, this is just the video capture sample, the old one, the normal one, completely. Okay, so let's run that one. Do you see what is happening? So this is now we're basically getting a display of the camera feed is all we're getting. There's this little buffer down here, but that's just it's just the camera feed. This is just a mistake, or maybe not a mistake, but what I'm saying is the camera is filling all the frames are just filling the whole display. Okay, so if we were using something like this, okay, if we were using something like this camera feed will just fill it all here, okay. And then if we actually alternatively run the one that we ran before, so that is samples subsys, this one, the video display one, the sync one, you can see that the camera capture, or rather the capture from the camera, is squeezed to one side of the display. So you have, it basically has already done a memory to memory thing, where it has captured something from the camera, but it is only showing it as a partial example of the screen, or rather as a partial. It's only showing it as a part of the screen. So here you see, that's actually, I found a thing. I want you to look at the logs, Bartholomew. I don't know if you can see the logs. So let's look at the logs here. It starts Zephyr display sync. It starts a display device. And then after it starts a display device, it starts pulling in the buffer from the camera. Look at those two. And then it will go slow, but I want you to, perhaps we can even, maybe you can even edit the code so that no, we can't make it slower. We would have to edit LibMP itself, and I don't want to do that right now. So let's look at it again. I'm going to run it. See, number one, just the display, and then shortly after, the camera feed shows. So it starts the display, and then it starts the buffer feed. And the buffer feed is just a part of the display. Okay, this will be even more obvious if we do this. Instead of camera display, let's do camera transform display, so that you can actually see this better. Is it sort of making sense, Bartholomew? Ask questions. Did I not use SW generate or something? SW video. SW video generator. Okay, cool, that's fine. So let's actually just go back and look at the camera transform display, and then look at the readme board with video display, and then what does it want? So it wants, how do I run this? Samples. I should be able to run this with something else. I don't see me eating anything. I don't see me eating anything, but let's see what is missing. So the thing I'm really confused about is where are where's the device trees? Where's the device trees? Yeah, where are the device trees? I guess the device trees are in. Okay, so it's because he's using device trees that already natively, because I suspect that this board MIXM MRT. So let's actually just look at RT685 EVK Zephyr boards. So I suspect that the boards that he has there already have a display display and so let's do RT first of all, 1170, and this should be something here. Yeah, cool. So this is AVK, this one, and it probably comes with the display and audio, that, and this probably comes with yeah, so it comes with a display, and it's also going to come with a video sensor, yeah, camera sensor and a display. So what basically is happening here is that he's using boards that already have the reason I'm not finding the device trees is because he's using boards that whose if we go here, if we go to the sources of this board, we will discover that there is a display already in the DTS, any of them, CM7 or whatever. There should be a common one. DTSI probably. We will discover that there's, I think it should be in Chosen, no? Should be in Chosen or something. But there's gonna be a display one, and there's going to be aliases, not aliases. There should be a display one, and there should be so that's not the one. So let's look here. Okay, cool. Let's look here. Fine. Yeah. So we discover that there should be a display one and a camera one. Zephyr camera, not here. This is CM4. Let's look at the CM7, I think. That's the one you would rather use. Chosen, there's going to be a console, there's going to be a flash, there's not a display. So, but yeah, MIPI connector, that's a display. Okay. And NXP cam connector, it's already there too. So yeah, they're here, they're just not chosen. It's just something else that chooses them. I guess this is why I said it's better if we use if you remember correctly, this is why I said it's better if we try and actually use NXP hardware, because this library is coming from NXP. And I think the other one we wanted to do was RT685, if I'm not wrong. RT685, that also should come with a display. 685, and this is gonna be RT. So 1, okay, this is good, that's fine. So let's look at this one. This one also looks like it comes with a lot, and I think I want to look at the features, and let's see if it comes with some sort of display features. Serial sensors on board, 6 axis. No. Should come with either a camera, audio, there's that, and CPU, ADC, counter, DMA, hardware information, I2S, I2S. There's no smart DMA or something. SDHC sensors, just that. Cool, but I don't see a camera. I do not see a camera. Okay, cool. So let's look at this. 2 onboard D mics, audio codec, Arduino. Wait, where am I looking at? I mean, LibMP. This is audio examples. Cool. So this one is just because there's audio examples here, so it's fine. So yeah, boards, there's that one. And then there's only one board. It's M1176 CM7. 1176 CM7. Is it a different one? 1176. No, it's cool. 1176 CM7. Yeah, that's the one we looked at. So it doesn't. So it's cool. B overlay. So yeah, let's look at that. CM7B flash code. No. CM7A. CM7A. B overlay. 4B overlay. CM7 YAML. Okay. No. It looks like they don't exist. But basically, what I'm trying to explain is that the boards that these samples use already come with a camera and already come with a display. So it does not need to be modified in any way. And what the other thing we can't do is sort of, let's actually try and build it for, can we copy app.overlay from where? From where do we get app.overlay? Can we get an app.overlay? So yeah, this is one I want, or LVGL demos. This is one I want. App.overlay, this one. So I want to copy that one and build for the FRDM MCX N236. Okay, I want to copy that one and build for that one. So cp samples subsys USB UVC app.overlay, and then I want to go into samples subsys LibMP video examples, and then in video examples I want to do camera. I don't want to do camera transform camera display, and I want to do app.overlay. That is it. And then instead of all of this, so here, rather than just build it with a software generator, I want to see if actually this just gives me enough RAM. Okay. Yeah. So let's remove the software generator. Let's leave the pristine. Let's remove the software generator. And then let's leave let's remove that, and then we can do FRDM MCX N236. I doubt we'll have enough RAM. That's what I think. The RAM is just gonna run out, and it's gonna be like, nah, not enough RAM. Because a frame won't be able to fit in RAM. That's what I think is going to happen. Yeah, I think it's going to go like, nah, you don't have enough RAM on this thing. And if it doesn't go like that, that means we have to get a display real pronto so that we can do this and actually see it work on an actual device. Yep, that becomes the problem. Oh, cool. So I kind of understand what's happening here. It needs more. There's a chosen display. Okay, it needs a chosen display. Cool. Let's try that. Yeah, so we're trying to see if this thing actually ends up running. Trying to see if it actually fits in RAM. And if it does fit in RAM, that means we can actually get a display and run it on this display. And run it on this little board, which would be quite interesting for sure. That is suspiciously close. Yeah, so as you see, RAM overflowed by that much, so we don't have enough RAM. And I think we can do. Can we do software generated display? How do you mock a display? Let's actually look at Zephyr LVGL. The other thing is we can do, they should say something like you don't even need an actual display. I thought there would be I thought there would be a way of simulating. So I thought you could simulate a display. Yeah. I thought you could simulate a display, and then we would have tried this on the N6. Okay, cool. Well, anyways, thank you so much today. That was an attempt at running. The new Zephyr RFC LibMP, and actually we did manage to run it. We did manage to see how it works. I think now the best cost of action is to start actually building, trying to see how the code works and how it all builds together and how it all pulls together and such. Thank you so much for coming to my class today, or my lecture today. My name is Zach, and as always, please try and be daring, and I'll see you guys next time. Thank you. Cheers.